All right, in this example, good news, we have a right triangle again. The 34 degrees is our known angle. I don't have to put a mark on it, but if that helps you to say, here is my reference angle, here's where I'm starting at, this is where everything is revolving around, it is a known quantity. From this 34 degrees, the 5 and x are significant. 5 is significant because we actually know it. X is significant because we want to know it. So what you need to do is label those two sides using the words opposite, adjacent, hypotenuse. 34 degrees is opposite the x. The 5 is adjacent to the 34. Hypotenuse is the one that we don't care about. We don't know it. We don't care about it, so it's irrelevant. And now think trig function, SOHCAHTOA. What trig function wraps together opposite and adjacent? That would be our tangent. It's TOA. The tangent of 34, I actually know the angle this time. It's not an unknown. The tangent of 34 is equal to the opposite of x divided by the adjacent of 5. So I'm using SOHCAHTOA. I'm writing the equation. The tangent is O divided by A. And now I have to think algebraically again. Unlike the previous ones where we were trying to find angles and we took trig inverses, this time we know the angle. So I'm not taking a tangent inverse of anything. This tangent of 34 is actually a number. I could type it into my calculator. It is a value. No, I've got to think algebraically. What would we have to do to get the x all by itself? Because right now it says x divided by 5, right? What's the inverse of dividing something by 5? So if we multiply the right side by 5, x is all by itself. We wanted that to happen. But this is algebra, and since we multiplied the right side by 5, we're multiplying the left side by 5 also. So x is equal to 5 times the tangent of 34. Notice I put the 5 out front. I really don't want to put it behind it because you're only taking the tangent of 34. If I put times 5 at the end, it might be unclear that you're supposed to multiply the 34 times 5 first and then take the tangent of it. So I really encourage you to put that number out front. So as far as our answer goes, the exact answer is 5 times the tangent of 34. And that is, again, a bit abstract. I don't really comprehend that, but it is precisely what it is. Then go to your calculator and type it in exactly the way we see it. We're not trying to find an angle. It doesn't have the inverse, so it's just typed in 5 tan 34. I'm getting 3.373. And I can make a quick check of this one. If I think that this length is 3.373, my quick check is 34 degrees is across from that side. This length of 5 is across from the other angle. Well, I know it's a right triangle. These two angles are complementary. 90 minus 34 would mean that this angle is 56 degrees. I don't have to have that in there, but it does allow me to compare the gray side across from the gray angle. They're both the big angle and the big side. And then the yellow, smaller angle, smaller side there across from each other. That kind of comparison gives me a little more confidence in my answer. All right, turn the page. Similar problem. I'm going to pause for just a second here. Think about what we've done on previous ones. From that 70-degree angle, I see that 4 is the adjacent. I see x is the hypotenuse. SOHCAHTOA. Hopefully you wrote that at the top of the page. If not, maybe you already know it well enough so you don't feel like you need to write it, but it is our acronym for solving these triangles when we have right triangles. So CAH, cosine of 70 is 4 over x. There's my equation. Now I've got to think algebraically. I know the angle is 70 degrees. I don't need to take a cosine inverse of anything. The goal is to get x by itself. The problem this time is that x is in the denominator, and I don't really like that. I want to get x out of the denominator first. So I'm going to multiply the right side by x to get it out of that denominator. Multiply the left side by x, and it shows up over there. So this gives us x cosine of 70 is equal to 4. It doesn't get x by itself yet. However, at least it gets x out of that denominator. Last thing algebraically, to get this x by itself, x is multiplied by the cosine of 70. So I'm not taking a cosine inverse to get rid of this thing. No, I am doing the opposite of multiplying, right? X is multiplied by the cosine of 70. So divide by the cosine of 70. That isolates the x all by itself up in the numerator, no longer in the denominator. X is equal to 4 over the cosine of 70. So the exact value is 4 over the cosine of 70 degrees. And from there, go to your calculator.
Could you just divide by 4? I'm going to have 4 over x. Could you just divide by
4? So this was the original equation we got using SOHCAHTOA. If you had divided both sides by 4, you would have gotten cosine of 70 over 4 is equal to 1 over x, because the x is still in the denominator. So if you did that, then what you need to do is flip both sides. So then if you flipped both sides, you would get 4 over cosine of 70 is equal to x over 1, which would be x, which is the same thing that we have over there. So it's another way algebraically that you can make that thing happen. I want you to analyze this one. Does this answer make sense? Again, the drawing might not be perfectly to scale, but based off of the numbers you see in the location, would you expect the x value to be something around this size? This length is only 4, and it's across from our smallest acute angle, right? And then this is our hypotenuse. It's across from the right angle. I would expect the hypotenuse to be bigger at least than 4, and probably quite a bit bigger. So I'm feeling pretty good about this answer. If I had got something that was less than 4, then I know for sure that I did something wrong. Hypotenuse has to be bigger than the legs. All right, number 9. Number 9 says, given triangle ABC, where angle A is the right angle, little b equals 5 and little c equals 8, solve the triangle. Now, this kind of problem, it doesn't have a little answer blank for us. It's not really clear, like what does it mean to solve the triangle? What are we trying to find? And the answer to that is you're trying to find everything. In a triangle, how many angles are there? 3. How many sides are there? 3. So how many things do you have to write in your answer? 6. Some of those things are already given to us, but we're still going to put them into our answer block. I'm going to draw the triangle. It says where angle A is the right angle. So here's my angle A. Little b equals 5. What that means is the side opposite angle B is equal to 5. That's the smaller of the ones. So what that tells me, if I'm trying to draw this to scale, here's angle B, here's little b. Little b is equal to 5. Then it says little c is equal to 8. So if little c equals 8, then this is going to be big C, angle C. These are the things that I know. These are the things that are given to us. As far as how do we write out this answer, the drawing is not the answer. I don't want to look on the drawing to find the answers. What I want to see is a nice organized answer key. How big is angle A, angle B, angle C? How big is little a, little b, and little c? Angle A was given, it's 90 degrees. I don't know angle B, I don't know angle C, so I'm going to put a little line underneath those just to emphasize the fact that I have to find those. Little a wasn't given, but little b is 5, little c is equal to 8. So it's a nice way to organize these. In the rows are the letters, capital A, lowercase a, capital B, capital C, little c. And in the columns are the capital letters for the angles and the lowercase letters for the sides. When you see these lowercase letters, again, those represent sides. The name of, like where it says little b equals 5, another name for that would be capital AC. Segment AC is another name for that. But in this context, we usually use the lowercase numbers just to organize them. So solve the triangle. We need to find everything. There's 3 more things to find. Let's start off with little a. After all, this is a right triangle. It's a right triangle. Before today, before yesterday, you knew what to do to solve a right triangle. In other words, Pythagorean theorem. So can you use Pythagorean theorem to find the length of this hypotenuse? So I'm getting that a is equal to the square root of 89. And I'm going to put just outside this blank square root of 89. I didn't even put it on the blank. I put it out there just in case I need to use that exact value letter. But in this context, I'm only going to need to put the decimal in here. So go ahead and take the square root of 89. .434. And then we have to go after angles B and C. Now, I found the length of this side. If I wanted to write this in here, that would be fine. But the 9.434 is a rounded number. I could put square root of 89. That way I'm not using a rounded or tainted number. However, I could have made a mistake. And I don't really like the number square root of 89 as much as I like the number 8 and I like the number 5. So I'm going to focus on those two as I try to find these other angles, specifically starting with angle B. Here's where we go back to the world of trig. Relative to this angle B, label little b and little c. Label them in terms of opposite, adjacent, and hypotenuse. So from angle B, 5 is the opposite, C is the adjacent. Trig function be tangent. The tangent of angle B is equal to the opposite of 5 divided by the adjacent of 8. It is TOA. We're trying to find the angle. We want to get angle B by itself. This is the time we'd use the inverse. So B is the tangent inverse of 5 over 8. .005. So we've got that. And there's multiple ways we could finish this. I want to keep my answers as precise as possible. Once you have angle B in your calculator, what could you do with that to figure out angle C? Take 90 minus that, right? So on my calculator, I could do 90 minus that second answer. I don't really want to type all that in. And occasionally, actually not occasionally, eventually we'll be having to use these values going forward. So I don't want to round it at all anyway. So I'll just take 90 minus that answer, 57.995. We took 90 minus B and got that approximate answer of 57.995. The other way we could have found angle C is to look at the relationship to the 8 and 5 compared to C. So from angle C, 8 would have been the opposite, 5 would have been the adjacent. So I could have said that the tangent of C is equal to the opposite of 8 divided by the adjacent of 5. take the tangent inverse of 8 over 5. So the tangent inverse of 8 over 5 also gives us that exact same answer. Even if you look at all those decimal places, they're still the same. It's a way I could check it if I wanted to. The answer is all of that. Don't just say the answer is those unknowns that you weren't given. To solve the triangle, you need to say everything. I think it's a good idea to underline the ones you're finding just to make sure it's clear that's the work you had to do. Don't underline the other ones because those were given. Those were rock solid. I know those to be true. And I don't need the square root of 89 circled. If you circle, it's not going to like be wrong or anything. But we're just looking for the decimals in this context and take everything to 3 decimal points or the nearest thousandth. All right, last one. Oops. Good old Parachute Pete and Jetpack Jana. So Parachute Pete's eyes are 70 inches off the ground. He's looking down at Jetpack Jana's shoes with an angle of depression of 80 degrees. How far away is Jetpack Jana standing? So 2 people. There's Pete. There's Jana. There's Jana's shoes. Parachute Pete's eyes are 70 inches off the ground. Okay, so here's his eyes, 70 inches off the ground. He's looking down at Jana's shoes with an angle of depression of 80 degrees. So from where his eyes are at, he's looking down at her shoes, and the angle of depression is 70 degrees. When I drew that, I don't see an angle in there, right? Here, his red eye looking down at her shoes. There is no angle up there. Angle of depression doesn't exist yet. Here's what you need to know about either angle of depression or angle of elevation is the other term. It's always measured from the normal. So imagine you're walking down the street. As you're walking down the street, are your eyes looking straight up in the air? Are you looking straight down at your feet? No, aren't you normally just looking straight forward? Like pretty much? Like that is a typical. So when it says angle of elevation or depression, the angle is formed by the line of sight, which I have drawn in here in red with his laser beam eyes, and a horizontal line. So normally Pete would be looking straight forward. Now he's looking down. Here is our 80 degrees. So angles of elevation and depression are always formed between a horizontal line and the line of sight. This is 80 degrees. Now, interestingly, this is horizontal in yellow. The ground is horizontal. This line of sight serves as a transversal. So what would you know to be true about this angle of depression coming down from his eyes and the angle of elevation coming up from her feet towards her eyes? Going to have to be equal, right? We say those are alternate interior angles. Parallel implies the alternate interior angles are equal. So I have a choice of how I want to draw this triangle that I could then solve. I could draw this segment coming straight down, which would give us a triangle over here on the left. Or I could draw it from this point directly above her shoes and have it going down. Those 2 triangles would be congruent to each other. I'm going to take the second option. Here's my 80 degrees. This height is going to be 70 inches. And then this length across the top, this segment is the same as this segment. That's how far away they are standing from each other. And our goal now is to solve for x. So I'm taking these words, drawing the scenario as good as I need to. And now I have a triangle, right? When it says height is perpendicular going straight up and down in the air, horizontal line of sight. That's how I know there's a right angle right here. Now it's the time for your trig. Look at the angle that we know. Look at the sides that are important, what we know, what we want to find. Can you set up the trig equation? Label your opposite and adjacent. Those are what we have. It's TOA. The tangent of the 80 is the opposite over the adjacent. Do the correct algebra. I showed you one way to do it. Joshua came up with another way to do it. Both are fine algebraically. Once you've done a few of them, you can kind of see how they maneuver each other around. X equals 70 divided by the tangent of 80. To make sense of the answer, Parachute Pete's eyes are 70 inches off the ground. That's where he's looking from. He's looking down at Janet's shoes with an angle of depression of 80 degrees. Looking down at 80 degrees, so normally looking straight forward, and then crank the head forward so you're rotating at 80 degrees. You're almost looking straight down. If it was 90 degrees, he'd be looking at his own feet. So looking almost straight down. How far away they're standing? Well, they're not standing very far away. They're only standing away 12.343 inches from each other. Think about that. How far is a foot? They're only about a foot away from each other, about 12 inches, right? So they're standing very close. He has to look almost straight down in order to see her feet.